Let's go ahead and take a look at example 2 on page 489, because we're going to see how to do a two-tailed test here. So a right-tailed test would be done just like a left-tailed test, except obviously alpha, it'd end up in the right tail. Or if you were looking for the p-value associated with the test value, you'd be looking at the area in the right tail. So not really much different there. Well, here we go. Example 2 says, when asked, what do you think is more important, to protect the right of Americans to own guns or to control gun ownership? 46% of all Americans said protecting the right to own guns is more important. Look, you guys can discuss that topic in another class. We're just going to do the statistics here, okay? We'll steer clear of the politics behind the problem. The Pew Research Center, I hear that place really stinks. Sorry, I couldn't resist. The Pew Research Center surveyed 1,267 randomly selected Americans with at least a bachelor's degree and found that 559 believe that protecting the right to own guns is more than important. Does this result suggest a proportion of Americans with at least a bachelor's degree feel differently than the general American population when it comes to gun control? Use the alpha equals 0.1 level of significance. Okay, so whenever you get your test, and you're going to be working on these hypothesis tests, the first question you're going to ask yourself is, what am I testing about? Is the question about a mean? Is it about a proportion? Or is it about a standard deviation? And if you go to the part of that problem that starts with the sentence, does this result, look and see what it says. Does this result suggest the proportion of Americans with at least a bachelor's degree, blah, blah, blah. So we're testing about the population proportion here, and that's how we know we want to use this test, which again in this section we've called the 1 prop Z test. Technically, we would have to make sure that our 3 criteria are met. Simple random sample. The problem told me this sample was a simple random sample. Number 2, n times p naught times 1 minus p naught greater than or equal to 10. And number 3, n less than or equal to 0.05 times big N. But to save us a little time, I want you to assume on this problem that those 3 are met. So let's assume that we can perform this test. Okay. Well, any hypothesis test we do, we're going to work through our 5 steps. Those 5 steps are not going to change. Step 1 is always going to be get H naught, get H1. All right, so our H naught here is P is equal to 0.46 because that's what we believed to be true coming in, right? We believe the general population, 46% believe that gun ownership is more important, or protecting the right to gun ownership. Now, what is it that we're seeking evidence to find? That's always our H1. That's right. Now, the question is always going to be here, is it P greater than 0.46? Is it P less than 0.46? Or is it simply P is not equal to 0.46? Our question says, does this result suggest a proportion of Americans with at least a bachelor's degree feel differently? We don't know if they think it's higher. We don't know if they think it's lower. We're just asking, is it different than 0.46? So this is going to be a two-tailed test. P is not equal to 0.46. Step 2 is easy cheesy lemon peasy. It's always find the alpha. And this problem says use alpha equals 0.1 level of significance. That means we only want a 0.1 probability of making a type 1 error, of rejecting that P is equal to 0.46 whenever it's really true. It's also going to mean that 0.1 is somehow going to end up in our tails. Okay? All right, step 3 is to go get the test value. Again, that's always step 3. The test value for the one prop z test we have noted is p hat minus p naught over square root of p naught times 1 minus p naught all over n. We've got all of that except for the p hat. The p naught is the p associated with h naught. It's 0.46. And I don't remember what n is. We'll have to go reread and find that. And we'll have to reread to find p hat. So what was our sample proportion? Okay, the problem said 559. 559 believed that it was more important to protect gun ownership out of how many? 1267? Again, that's x over n. And let's get that to about 3 decimal places. And we're looking at 0.441. So now substituting into our formula gives us 0.441 minus p naught is 0.46 over the square root of p naught is 0.46 times 1 minus p naught is 1 minus 0.46 all over n, which is 1,267. Now, can we assume that at this point you're okay with punching that in on your calculator? Okay, if you crunch the numbers there, according to your textbook, you end up with negative 1.36. Okay, now, what do you guys want to do first, classical or p-value? Let's keep it in the same order that we did the last one. And by the way, on most problems, you would do one or the other. There's no reason to do both. They're going to give you the same thing. So in your text, they're probably going to ask you for one or the other, but not both on the same problem most of the time. So let's do classical over here. All right. With the classical approach, our first job is to find the critical value, or in this case, critical values. Now remember, to do that, what we do is alpha goes in the tail. We find the z-score that goes with it. Which tail? Well, what kind of a test do we have? Aha! Way to go. She's thinking. She's learning concepts rather than memorizing. That was beautiful. The question was, what kind of test are we doing? Which tail? Well, if you look back, it's two-tailed, isn't it? So we're going to put alpha in both tails. Okay, so what was alpha? 0.46. No, that was p hat. It was 0.1, right? So then I'm going to split that 0.1 up and then between the two tails. So if I divide 0.1 by 2, I'll get 0.05. So we're going to put 0.05 in the right tail. And we're going to put 0.05 in the left tail. Okay, so if we're looking for a z-score, that's an inverse normal problem. And for this left one, if I just inverse 0.05, my calculator understands left tail area. And if I inverse norm 0.05, I get negative 1.64, which is one of my critical values. And since the normal curve is symmetric, this value on the right side then is going to be positive 1.64. So here are my critical values, and there's my shaded region, or my critical region. Now, look in your notes and see what the question is that we have to ask now to figure out whether we're going to reject H0 or not. Is what in the shaded region? It is not if the critical value is in the shaded region. Remember, the critical value is always going to be the start of the shaded region. Is the test value in the shaded region? That's right. And our test value, or test statistic, if you prefer, was negative 1.36. So, where would negative 1.36 be? It would be back here somewhere, wouldn't it? It wouldn't make it to the shaded region, which begins at negative 1.64. So, the critical values, the test value is not in the shaded region, so we do not reject H0. And our conclusion would be is that there is not sufficient evidence to show H1, and that's that the proportion is different for those with a bachelor's degree who believe that protection of gun ownership is more important at alpha equals 0.1 level significance. Okay, so if you had to write a conclusion, that would be the conclusion. Well, how about... Okay, we ready for a little p-value action? Here we go with the p-value approach. With the p-value approach, if you check your notes, it's going to say to go find the area related to the test value. Okay, so draw me a normal curve. What was my test value again? Negative 1.36. Okay, now here is where we got to do a little thinking. It's a two-tailed test. So am I looking for left tail area, or am I looking for right tail area? The answer is I'm looking for both. So I'm looking for this left tail area. So we're going to find the area to the left of negative 1.36. And then we'll go over here to positive 1.36 and find the right tail area associated with that. So whatever your test value is, change the sign on it and find the other area as well. Now, really, both of these areas are going to be the same. The curve is symmetric, right? So really, if I just find one of them, say I find this one over here, I can just multiply it by 2. That'd give me the whole area? No. If I do the first one, it's going to give me this left tail area. If I multiply it by 2, it'll give me that left tail area plus this right tail area. So it'll be everything except what's in between. Okay, so I'm going to norm CDF, negative 1 E99, comma, negative 1.36. That gives me 0.0869. So again, I norm CDF, negative 1 E99, comma, negative 1.36. That's what I just did. It gave me a number. So to get both tails, then I'm going to take whatever that number is times 2. So I'm going to go times 2 now, and I get 0.1738. Which is known as the p-value. By the way, when I say p-value, it has nothing to do with p-naught or p-hat or the population proportion. Okay? That's not what it is. It's the probability of getting the test value. That's what the p-value is. Okay. What's the question then that I ask once I get the p-value so that I know whether to reject or not to reject? Right. Is p less than alpha? Is 0.1738 less than, what in our alpha on this problem, 0.1? It's not, is it? That's not true. So since p is greater than or equal to alpha, again, we do not reject h naught. Hey, that's going to take some practice, isn't it? But listen, once you get it, you set yourself up golden for the whole rest of the semester. Okay? But if you don't get it, then the flip side of that is we're kind of in trouble because everything we do moving forward is a hypothesis test.